I'm Silas. I'm one of the senior product managers at Zoho Analytics, and I take care of the product management for this particular module, which is recently introduced in the platform in 2024 September, which is last year. In this session, I'm just going to touch base data science and machine learning in the BI workflow. So the BI is the business intelligence, right? So you have the analytics flow. So how data science works along with the BI workflow, because data science is a generic topic. Okay, it is not scoped to analytics or BI in specific. It's always so generic. So, I mean, um, I just explained this in the previous session as well. If you typically take the data space, the data science or data management, analytics, and all this data related space, right? You typically find three professionals, three designations in the market, right? You have somebody called data analyst, and their role is to build the reports and dashboards for organizations. Okay. And you also see somebody called data engineers. Data engineers are nothing but they take care of data management, large volume of data, preparation, scaling, cataloging, and all those stuff, right? So, data engineering activity. And you have a designation called data scientist. And, like for the last few years, it was one of the top paying jobs. It was trending and all those stuff. And the reason is these professionals or somebody who build machine learning models, which is more customized and personalized for a particular business. And that helps a business to do a lot of things in more better way. When I say a lot of things, be it prediction, like let's say, what will be my demand forecast, what will be my sales forecast, or how I can give some recommendation to a customer, or probably how I can find whether a customer will churn in my business or not. So all those this prediction and futuristic things happens as a part of the data science activity. Okay. So the role of these data scientists is to build ML models by understanding the business use case and customize and personalize it to work it for that particular use case, right? So that's the role of the data scientist. Now, in this session, we're going to talk about this DSML in the context of BI, because it can be also generic, right? So you can build ML models in a platform like Amazon. I mean, not AWS, but let's say Amazon as a business, right? So Amazon as a business, how do you get the product recommendations? Like whenever you purchase something, you get the next recommended product associated with that. It's just not just the same category. It can be a whole lot of things which is associated to the product, or when you just come back to a home screen after 1 month of time, you say different set of suggestions. It's based on your demographic, your age, your location, the top trending products, your buying pattern based on this the range of the purchase size, each and every product, like what is the average cost that you spend per purchase, whether you opt which has a lesser delivery date, whether you go with like higher review rate, all the stuff it'll check and give you the suggestions appropriately, right? So it's that also DSML, that behind the scenes it uses the machine learning to do the same. Okay, so it's not in the context of BI analytics, it's generic. Okay, so we are going to touch base the DSML in the BI workflow in specific, and also we'll see some of the common use cases where you see the data science and machine learning comes up. And there is a big life cycle in terms of this model building and analysis and all those stuff. I'll touch base what it is. And then we are going to talk about two important capabilities that we offer as a part of this particular topic. So in terms of this DSML workflow, the data science and machine learning workflow in the context of BI is starts from data connection and data management. So this is something that we already discussed as a part of the BI or analytics workflow and data preparation and management workflow. So you have to connect and consolidate all your data in one place for data science process. Second, you get into the data management, which is nothing but like you go ahead and prepare, cleanse, transform, enrich, do all those stuff to ensure that your data is prepared for this data science activities or even analytics activities or anything. Without going through these two steps, you cannot go ahead and do the prediction at all. If you do the prediction on top of some raw data which doesn't go through the process of preparation, your prediction is going to be even more mess up, to be honest. Because when it comes to this prediction and data science and all those aspects, it's always futuristic. It's not like something that you're going back and do some history on it, right? So it is always kind of like a trial and error method. You cannot precisely say that, like, hey, this particular customer will churn out for sure, or this particular customer will buy for sure. We cannot do 100% precise prediction, but the closer 100% accuracy that you take, that's the role of the data scientist in organization. So to do that, you need a good data in place. And to have a good data, first you should prepare and consolidate your data, and only then you can get into the any, not just this DSML process, any agentic AI or any AI concept, you need a good data. Without good data, your responses are going to be messed up. Third, the data science comes in into the BI workflow. So once you have this data consolidation happens, and once you have your data management happens, then the data science and machine learning comes in when you need this advanced analytics cases like prediction, forecasting, clustering, and all those stuff. So when it comes to this data science aspect, there are different stages, and that's what I was calling as a life cycle, right? It starts right from building a model, training a model, analyzing a model, deploying and archiving and managing, and all those stuff comes in as a part of it. And finally, you get into the insights and actions, which is nothing but building the visualizations, analyzing what's happening, what will be the outcome of those models, and all those stuff. So that's the four different stages. So the data science comes in after preparing and enriching and transforming your data. Now, some of the common use cases when we talk about the data science and machine learning, as I said, predictive analytics. It's always like forecasting your sales, customer churn prediction, and demand forecasting, and a lot more. Clustering the data. So, for example, you group the data based on a lot of parameters and criteria, and you take that list, and probably you'll be sending an email campaign, or probably you'll be grouping and analyzing what could be your next product or next service that you're going to launch, right? So, all those analysis can be done through this clustering aspect. So, it's kind of like it's segmenting the feature based, segmenting the project's workload or anything based on various parameters. Third one, anomaly detection. So, for example, let's say you get into the process of financial transaction analysis or like fraud detection, right? Right. So, anomaly detection in a transaction. So, all those things can be also incorporated with very big ML models in place. So, these are all common use cases in BI and analytics in specific. Now, let's get into the data science life cycle. So, when I say the life cycle, it's obviously it has to go through like different stages to close, right? And on that front, whenever it comes to this analytics, the life cycle is like connecting data, preparing data, analyzing the data, publishing it, collaborating, and all those stuff. Like that's the life cycle, right? So similarly, if you build a product, like you start with research, plan, UI, and then you get into the development or engineering, and then testing and release, right? So similarly, the life cycle involved in the data science and machine learning is like 5, 6 different steps. Okay. First one, as I said, data preparation. If your data is messed up, if your data is not clean, you have to stop this activity. It doesn't make sense to put any effort in it without prepared, cleansed, and a very good data. In technically, they call it as golden records. You should have very cleansed, prepared, unique records for each and every customers or all those stuff to ensure that your data is ready for data science activities. Second, the machine learning model building. The ML machine learning model building is nothing but it can be done through multiple ways. So it can be done in any language. The programming language that we talk about, but typically it's done in Python, right? So you build ML models in Python. You cannot do it in R, or you can do it in various other languages. But in the data science space or in the data science world, people build this using the Python environment. Okay, so that's one thing. But when I say this ML model building, it is not necessary that you have to invent this or start this journey right from the scratch. You have tons and tons of models available in the market, right? Right from decision tree, random forest, and a lot. So you have like a lot of models published and already available in the market. There are a lot of models available which is more industry specific. For example, a specific type of prediction model works good for a manufacturing industry in terms of like maintenance prediction, facility management maintenance prediction. So all those stuff comes in as a part of specific industry. So you can find ML models on those aspects as well, on those lines as well. But however, always you got a choice of building these models right from the scratch also by referring multiple models. And that's what they call it as ensembling or multi-model techniques and so on. So you can also take things from two different techniques or two different models and do it together as well. So model building is the key process. Okay. And once you build this machine learning model, you have to train it. Okay. Now, this is the complex part. If you're not into this data science space, if you're not into this machine learning part, you will be wondering what is training, how I can go ahead and train this model and so on. I'll just keep it simple. I'll just make this process very simple. Let's say I just want to do the churn prediction. Like, I just want to see whether this customer will churn in future or not in my business. Okay. To make this work, what I'm trying to do is I already have like 5 years of data in the history, and I have the list of customers who churned from my business. So I know that this could be the pattern my customers typically churn in my business. So I take that historic data and I feed this machine learning model saying that, hey, this was my pattern. Okay. Can you train yourself and be ready so that I will give you my current data, like my existing customer list, and that list, this model will understand that, hey, okay, this is how the history was. So assuming that these activities will go ahead and churn. So it's not just, I'm not talking about like five different conditions here, like let's say condition one, condition two, condition three. And if you're out of these three different conditions, when I say like if customer is less than 30 years, and if the customer is based out of eastern zone or probably like northern part of US, and if the customer is certain so and so on, they're not going to buy this product. So we are not going to make decisions just based on the two or three steps. Whenever this comes to this machine learning model building, the process is going to be very, very heavy. We typically talk about like 500 different parameters easily, right? 100 different parameters easily just to get started with. Okay. Because if you want to just do based on three, four different conditions, then you can do it in a formula. You don't need a machine learning, right? So you need a machine learning model when you have that kind of like a very deep use case where we talk about like 100 different parameters in a business or 1,000 different parameters in a business. So based on all those parameters, based on all those logics and techniques, and based on your historic data, this model will be training on its own to give you that recommendations and suggestions. And that's what we call it as a model training process. So we take the prepared data, we go ahead and build the model, and we train it with the historic data set, right? Fourth, model evaluation. So it's kind of like what we call it as model analysis. Okay. What is this? As I said, this is not a one-time process. Typically, if you take enterprises, they have data scientists who typically going through multiple iterations to get this result. It's not, once again, the result is not precisely like this is 100% correct. No, but it will give you certain level of accuracy. To attain that level of accuracy, the more and more accurate rate that you have, the model is better and well shaped up. But once again, when I have interactions with a lot of enterprise data scientists, they say, no, we are not just using one models. We are using like 4 or 5 different models based on seasonal factors, based on some new marketing activities and all those stuff to do those predictions and plannings and all those stuff. Okay. So it's a very big process. You need archiving, you need iterations. So you take a lot of parameters as an output to measure whether the model is right or wrong, or at least how much it is relevant to your business use case or not, right? And that's the process called model evaluation. So you build it, you train it, you see the output, and you decide whether it is going to work or not. then you're going to make some further tweak in terms of the model building, and then again you're going to train it with the latest data, and then again you're going to do this model evaluation to see whether it's going to work. So it's always an iterative process, right? Then deployments. So whenever I'm talking about these models, ML models particularly, it cannot be just run on a small machine, which is like 2 GB, 3 GB machines and so on. You need like a very big service for very deep neural networks and very heavy models. Okay. So the system should give you a provision right from a 1 GB memory. The memory is like a processing memory in terms of servers, all the way till like 128 GB or something else, which allows you to process those heavy lifting models and learning things. So deployment is kind of like an infrastructure where you can use it seamlessly, dynamically to do these heavy lifting things, right? And finally, manage and monitor. So one of the discussions I had recently with one of the customers last week is they said, um, do you have something called drift analysis, which we don't do. We are planning to work on it, which is nothing but his particular model was trained till 2024 first 6 months data. Okay. And then now, as we are almost like second half of the close to the end of the first half of the 2025, now what happens is they say like, okay, the model is dated now because the data is old, right? So you have to manage and monitor and retrain, saying that, okay, this is the latest data, this is the latest pattern I see in my business. So get trained and give me the output accordingly, right? So this is the complete life cycle of the data science and machine learning aspect, right? So this is kind of like a very long process. It sounds like complex, but if you really need to get into this layer, you have to go through some of these things. We made it certain things easy, but since we have a mix of audience who are new to the data science and we have somebody who knows what is data science, and just going through all these processes in detail to ensure that everybody understands this clearly. Now, how we solve this problem, what we do from Zoho to handle all these things, whatever I have explained. So what so far I have explained is more generic of what is data science, how that works, right? Now, when it comes to this data science and machine learning capability, we have launched these features recently called AutoML, which is like automatic machine learning model building. And the second one, what we call it as Code Studio. Okay. So let's focus on the first one. What is AutoML, right? AutoML is nothing but, let's assume that you understand the concept of machine learning. So when I say the concept of machine learning, you're good in terms of understanding how logically a particular model works, but you don't code. You don't go ahead and sit and do the coding, as you're not a developer, right? But you're a business user. You're good enough to understand how a model works, the logic of the model, you know that. Then you can use this feature to build a machine learning on your own without any coding, zero coding. Okay. So when it comes to this AutoML, there are a lot of different types of analysis available, but currently we start with two key things. We're going to expand this a lot, but we're just focusing on two things for now. One is prediction modeling, the other one is called clustering modeling, right? These are all the common use case which solves many problems in the business. So when it comes to the predictive models or prediction use case, so whenever you click on AutoML at the left on your screen. So for example, let's say this is the user interface. I'll also have a video to show in detail, but still, this is the user interface. And by the way, this is not enabled for all pricing plans. So certain pricing plans, you need to contact us to enable it. But once it is enabled, at the left, you will find something called AutoML in the left pane. Once you click on it, it takes you to the screen where you have a choice. So as soon as you just choose AutoML, you have a choice of choosing two different things. One is called, are you trying to do any prediction on your data, or you're trying to cluster your data set, right? So immediately we'll ask you two different details. So which I'll just go through that in the next screen as a video. Yeah. Here I just click on AutoML at the left. This takes me to the screen where I can create the new analysis, like new model building process. Yeah. So once I select this, it takes me to a page called Am I trying to build a predictive model or a clustering model, right? And immediately what we do, we ask you to choose a data set which is nothing but the training table. As I said, training table is nothing but your historic data. So in this example, we are trying to do a churn prediction. So assuming that I'm running a business like an e-commerce business, I just want to predict whether my customer will churn out or not. Based on that, I can do marketing activities, right? So on that front, now I have the choice of selecting my historic data, which is the training data, saying that this is my historic data, and you need to choose something called target column. Target column, nothing but you have like a binary column saying that yes or no. S is nothing but the customer was churned. No, the customer was not churned, right? So that's your historic data. So you choose a target column, you choose your historic data, and choose what you want to do in the AutoML. So once you do this, it'll take you to this next page. Of course, the clustering. For the clustering, you don't have a target column. So only for the prediction, you have the target column. So in this case, I'm just trying to do the customer churn prediction. So I choose the customer churn prediction and I choose this column called attrition flag. That's it. That's the step one. That's the step one for AutoML. The step two is model training. Okay. So when it comes to the model training, there are multiple factors in it. Like you choose the training data, you do something called feature engineering. You do something called hyperparameter tuning. The word sounds complex. I'll make it simple. So once you click on create model, it'll take you to this page. And in this page, you have selected the old churn data, which is the training data. And then you had chosen a field, which is like attrition flag, which is your, obviously your, the field which says whether you got an attrition or not. Then you get into something called features list. Features are nothing but column names in your data. That's it. Don't make it complex. Simple. Feature. The reason we keep it as features list, that's how data scientists says that. It's an industry standard. But just to simplify this crowd, let me say that features are nothing but the column names. So there are different columns in your data, which is nothing but your different fields in your CRM or something, which typically influencing these factors, right? So you choose those features. And then obviously the prediction type, there are different types of prediction type. What we are trying to do is a classification. Classification is I'm trying to group the data saying that these are all list of customers who might be churned in future, or these are all the customers who might not churn. So I'm trying to classify them. And then coming to the algorithm part. Algorithm is nothing but the machine learning models. There are n number of machine learning models, thousands and thousands of models out there in the market. What we do, we support 40 plus different models behind the scenes, which is like most commonly used in the industry. So when you do this churn prediction or some kind of a prediction based on your data, to get into the screen, it'll typically take like few minutes, but once you get there, based on your data pattern, based on your historic data, the training data, Zoho Analytics will automatically choose some machine learning models. So in this case, the decision tree is one of the well-known model. The random forest is a bit more complex than the decision tree, but one of the well-known model which is used. So it automatically predicts the algorithms or models that you can use. It automatically include the required data set for that model, but at any point of time, not at any point of time, but during the model building process, at any point of time in specific, you have a choice of including other features. Other features are nothing but other column names. For example, this is an e-commerce business example, right? So to predict the churn, the system automatically includes the income category, the credit limit, the revolving balance that they have in their account, or the number of transactions, the transaction amount, and all those stuff. But I prefer to include more parameters like a customer age or gender and all the stuff for selling some particular products. I can do that. So I always have a choice of go ahead and include those additional features and parameters like number of transactions or something. Then I can go ahead and check more details about those data set, which is nothing but before including a column, it get into the level of detail saying that like, hey, this column has value which has a distribution of minimum of 840, the maximum of 16,000 or something, the mean value, median value, the distinct value, the empty cells. So you can determine how deep it is. It get into the layer of what is the data quality you have, what is your pattern of your data, all those stuff. It get into that level of details, and it gives you all these featuring details, so you can decide whether you want to include the data or not for your model building process. But once you do this, then that's it. You're getting into the next stage of adding algorithms. As I said, there are n number of algorithms out there in the market. In this case, it automatically pick a couple of algorithms that works for you, which is the decision tree and the random forest. But let's say you just want to include one more algorithm called the gradient boosting classification. You can do that as well. And on the right, you see something called hyperparameters. Hyperparameters are nothing but you're making tweaks into the model. You're making some tweaks in that machine learning model, saying that, hey, this is how my machine learning model should work. It should go this deep, it should not go this deep, all those stuff. For example, you have something called nodes in your decision tree. Like, what is the maximum level of nodes that you want to take it? Like, what is your subsample levels and all the stuff? So, this is what I'm saying again. Just to simplify, you should understand what is this model. You should just simply Google it. Just simply ask OpenAI, saying that, hey, just explain in a simple language of how decision tree works. It explains you. Then you can pick that logic behind the scenes. So once you do that, that's the data science part. So once you do these things, you can go ahead and make changes out of it and everything, and you're ready with the preparation part. So you're tweaking your model training process by having different feature engineering, having different things. So that's the next thing. Then you get into the deployment aspect, right? So as I said, ML models always need a choice of deployments. So when it comes to Zoho, what we do, as everything is hosted in the Zoho cloud, we give you a choice of servers based on the deployments. So for example, some heavy models needs like 16 GB, 32 GB. This can be extended way higher than what you see in the screen. This can be extended up to like 64, 128, and so on. So based on your need, you can leverage some big configurations and you can use it appropriately. So this is how you start the model building process. So once you're done with this model building process, the next stage is analyzing the output of the model. So when you get into the next stage is pretty much simple. You will get a summary of a model. You will get how exactly that model performed and everything. So once again, let me going through a quick example here. So in this example, if you have a look at this, this explains the model details. Like we have picked a classification model, the decision tree model from which we are trying to do this, and what is the depth of the model, what exactly the training status, and all those stuff. You also get into a concept called explanation factor, meaning how exactly that model worked. What was the weightage given by the model? For example, this is an e-commerce business. So out of all those transactions that you have, this model has given weightage to probably the transaction changes that happen over a period of time, or probably the customer age, the amount change in terms of purchase, and all those stuff factored in to build your model. So this level of granular details helps you to understand how that model was built. What are all the things involved, included to build that model? Okay. And then you have something called performance metrics, partial dependency, and all those stuff, which is like, once again, it's all the machine learning, the model, the data science terms. Partial building, just to simplify how exactly your values are distributed inside each and every column. So you need to get into that level of details to build you these models. So you can understand what was the distribution, how it was taken, and all those stuff. Then you have few other parameters associated with the module which you can check to understand, right? And also confusion matrix and a lot more. So once you're done with this process, so I'm just trying to do this churn prediction. So once I do this, then I get into the process of after the model building, after the explanation factor and everything, then I get into the deployment, which is like deploying that in the production environment. This is just to give you a reference or an example of how exactly the decision tree works, right? So we just pick the decision tree for your customer churn prediction. So what is the logic behind the scenes in a decision tree? This is the pattern behind the scenes. I'm not explaining this in deep, but just to give you the glimpse, right? So it's like you're making 20 different decisions to decide whether the customer will churn or not, right? So, for example, what was the transaction value in the last 6 months, or average transaction value? If it is greater than $10, then you should consider, okay, we are going to the next decision. The next decision is how many transactions customer made, whether it is like less than 5 or greater than 5. If it is greater than 5, then you're going to the next stage. What kind of products customer bought? Whether the customer bought something like a simple groceries, which can be taken easily from a nearest Walmart or something, you can take that. So it's going to be like yes or no again. So you go through all these process. I'm not explaining this in detail. Imagine you're going through all these decisions in 20 different levels or 30 different levels. Okay. That's the customization that you made when you're trying to build a model at the first stage. Okay. So once you do all these things, then you build the model, you evaluate it, and you get into the model deployment, right? So the model deployment, as I have mentioned, you have a choice of servers to choose, and so on. So that's what you see here. So you can go ahead and deploy the model once you choose the servers and everything. Now, this is a common model that you have built for multiple purpose. For example, this model was built for one of your entities. Now you prefer to reuse it for other entity, or you prefer to do it for other set of data, right? You can do that. So it's a one-time model building process. Then you get into the process of choosing some random input, not random, the relevant input table. You can include some columns which you prefer to see it as an output or exclude that and so on. Then you go ahead and get an output table out of it. So you're just going to name it here. So this is the output data, which I prefer to see. Always the data will be in the table format. So I just go ahead and name the columns, which I prefer to see it as a prediction. You can schedule the process like how frequently this model should be refreshed and update. You can do that. So once you do that, it'll take you to the screen where you can see a new table created. And the new table will have a column called churn prediction at the end, which says whether this customer will churn or not. Okay. So once you're done with this, then you're getting into the analytics workflow. You just go ahead and start creating the reports saying that like, hey, what kind of customers typically churn? What is the attrition rate? What can be, I mean, what kind of like a typical retention rate, retention percentage, and all the stuff that you can do. All those analysis can be done, but also you can take this data back. You can use it for other purpose as well. Let's say to send the marketing campaigns or something else, you can do that as well as a part of it, right? So that's the process of the typical process of building things using the machine learning capabilities. So that's how the AutoML works. So it's a no-code way of building ML models, the machine learning models for your business use case. But please understand that this is not. I mean, it's not a lightweight, to be honest. You should know things to do this, but it's a low-code way of doing it. If you can put some time to understand how this works with the help of Google, ChatGPT, and everything, if you learn how a model works, if you learn what is hyperparameter tuning, how to tune it, then it's a game. You can build things, you can do the prediction, you can do a lot more stuff. As I said, it's not just analysis. You can take this data back to your marketing campaign to send campaigns. You can plan the entire activities accordingly, right? That's the first feature, the auto ML. And I took some time to explain that. The second one is fairly simple, and that really requires a developer expertise, right? So the data science expertise. So this particular feature is called the Code Studio. Code Studio is nothing but a Python environment inside the platform. Simple as that. So we have incorporated a Python environment right inside this platform, which allows you to do multiple things. One, machine learning model building right from the scratch. or you import some code from somewhere, some other servers, and you build your own things, or you prefer to perform some advanced data transformations, which is very complex in SQL, but it's easy in Python. You can do that as well. So it's a multi-purpose thing, but it can be used for model building or data transformations. So how this the machine learning code studio works? Simple. Once again, you see this option at the left. Once you choose it, you get into the process of ML models. So when you get into this ML models, you see this nice interface like a Python coding interface where you can just go ahead and code and take a copy of it, or just write a model, or you can import it from some different sources as well. At the left, you can see that you have different files options at the left. For example, let's say at the left, you can import the supporting libraries like pandas, numpy, and lot more, scikit, and lot more. Or you can also import any other supporting files which is required. So these are all the essentials for a data scientist or data engineers or developers to do data transformations or model building. So you do all these things, then you get into the process of data transformations is also the same process. But when you get into this, the Code Studio capability, it also has the contextual Ask Zia. So you can enable Ask Zia with the help of OpenAI, ask questions, generate the code, tweak your code, and move forward further from there. But still, you need to know how to deal with this using Python. This is a quick example of how exactly the Ask Zia works. So let's say I just want to generate a model to do some particular tweak or tune. So I'm just trying to say, like, I have a data frame with age as a number column. So can you give me a code to bin the name as age bin or something? So I just type in what I want. Like it's just a requirement text. So once I do it, I get the response contextually. I can just take that code and insert it inside my model, and I can start using it immediately. So that's the Code Studio. It's not available in all the pricing plans by default, but you can, if you need it in Zoho or something, get in touch with us through support at Zoho Analytics. We can enable it for you. And this particular feature typically works in the model of like pay as you go model. The reason is, of course, as a part of your pricing plan, you will get some credits by default. But if you need that to be used extensively, then you have to use something like pay as you go model, which is nothing but like if you build a model and you train it, like how much time that model was running in the server, that will be accounted in your pricing. And it's not a very big pricing, to be honest. It's just like one credit cost you 0.025 dollars, which is like way less than like a dollar or something for per minute or something. So you can use that to build models and use it accordingly. So 1 GB of memory to build this model, like the server 1 GB of memory server typically goes or consume like one credit. So one credit cost is like 0.0255 dollars, right? So that's how it works. But I mean, this is how industry works. Typically, if you go to the Amazon or Azure or GCP or wherever, the Google or anything, you have to rent the service, which is like slightly expensive than this. We have incorporated seamlessly right inside the context of Zoho Analytics for the machine learning purpose. Thank you.